welcome to this video. So this video will be about a conventional question in paper 1 of DSE about application of trigonometry in three-dimensional space. So ABCDB prime is a pentagonal paper card. So both equals to 40. And then 24. And then in part A1, we are asked to find the distance, ABC, okay, yep. So this equals to that, equals 80 degrees. So, now of course, okay, with this setting, triangle ABC must be congruent to triangle AB prime D. Right. So to find AC, so A1. So we just try to make use of the cosine formula. So AC squared equals 40 squared plus 24 squared minus 2 times 40 times 24 cosine 80. So AC equals so 42.9. So that's part A. And then angle ACB, this angle. So A2 sine angle ACB over 40 equals sine 80 over AC we find just now. So so 40 times sine over answer, last half it. So 66.6 degrees. And this one will be saved to B. And that would be for the first two parts of part 8. So here comes part A3. So describe how the area of the paper cut varies when angle BCD increases from 105 to 145 degrees. So instead of angle BCD, right? So that would be the objective angle. Now here I'm afraid, so if it's given that AB, so with all the green labels here, so I'm afraid the green triangle is fixed. This is fixed, no variation. And also this triangle, as I mentioned before, congruent to the triangle on the left, also fixed. So that's why here the only triangle which is not fixed, okay, so that would be the triangle here, the yellow triangle, triangle CAD. And this is an isosceles triangle. Right, so and then don't forget AC and AD, okay, so already found in part A1, and don't forget they are fixed, they are also fixed. So that's why the only variable, okay, so will be this. So if we can find an expression in terms of angle CAD, then it's a bit easier because 1/2 AB sine C can already find the area of the yellow triangle. Okay, so that's why here we can try to first of all angle CAD, and then plus 2 angle ACD equals 180 degrees by using the base angles isosceles triangle, and then as a result 180 degrees minus 2 of them, and then angle ACD can be expressed in angle BCD, which is the subject angle we want, minus angle ACB, and which is right, and which is the answer, okay, in part A2. Okay, so that would be 180 plus 2 angle ACB. So this is the constant part, minus 2 angle BCD. Okay, so once we can express the area in terms of angle CAD, we can also express the area in terms of angle BCD as well. So from the range, so we have 105 lines between, angle BCD lines between 105 and 145, and then we just try to make subjects. Okay, so with the answer in part A2, so that will be B. So we will have, we try to times 2, okay, 100 plus 2 beta times B, and then minus 145 times 2, right? Yeah, so that will be 23 point something. 18162974 is. And then at most, so that would be 100 V. So that's why this expression, so that will be angle CAD. So angle CAD, okay, will be within this range. Good. And then the area of the paper cut, so that will be equals to 1/2 times 40 times 80, times 24, and then times sine 80. So 1/2 AB sine theta, that will be the green part. Maybe try to use green then. Okay. So then we have 2 of them, and then plus the yellow parts. Can I use yellow then? So 1/2, oh good, AC square sine angle CD. Right, so and then that will be only the second part will be the only variable parts. Good. Okay, so you can see that the green parts, so this is constant. So the first part is a constant. And then while the second part varies as sine angle CAD. Okay, so this is really crucial. This is really crucial. We need to put that down, this one. Okay, so that's why the area expression here actually is a partial variation. The first part is a constant, and the second part, okay, would be directly varies as sine of angle CAD. So if a sine of angle CAD is more, okay, the more the value of sine angles 80, so the higher, okay, the area value. Okay, so that's why when, okay, would the area of the paper cup be the greatest? So according to psi rule, because we have the range, and then you can see this range, it will pass us through 90 degrees. Okay, so it will pass us through 90 degrees. So maybe I would need to have more space here. Okay, put it here then. Alright, so that's why the area is the greatest when angle CD equals 90, and that would be sine angle CD is 1. Okay, because according to the sine graph, so this part and height is 1, and then from 23 point something degrees, so that would be from here to here. Okay, so we are actually watching at this part. This is y equals to sine x. This part is 90. Okay, good. So when angle CD is 90 degrees, so let's see. So when angle CD is 90 degrees, so angle ACT will be 45, right? So because it's angle CD, so that would be like this. Right, so in that case, when angle CD is 90, and angle ACD would be 45 degrees. So if we try to define alpha equals to 45 plus angle ACB, which is a fixed number, okay, so we can try to make use of the answer, okay, in part A2, so which is 111.5908 degrees. We try to divide this, so we'll try to have maybe try to put here, so area will increases from 105 degrees to alpha, and then area decreases afterwards from alpha to 145. And that's why, okay, we have the complete picture. So I'm afraid this part, okay, will be the the hardest part, okay, of the whole problem. And that's all for this part. So here comes our part B. So angle BCD equals 132. Okay, so within the range, okay, in part A. And then the paper cut is folded along AZ and AD such that AB and AB prime join together to form a pyramid. So find the volume of the pyramid. Okay, so now I'm afraid here, so shall we wind before? So AC and AD isosceles, and then we have BC equals to BD, also isosceles. So in order to find the volume of the pyramid, so volume of a pyramid, so which is 1/3 base area, and then times the height. And then I'm afraid the base, okay, will be undoubtedly, okay, we'll take ACD as the base, but the height, okay, that will be difficult. Alright, so that's why I'm afraid we need to find the angle. How we need to find the angle between the green plane and also the yellow plane. We find the angle first, and then we can find the height. And the height, okay, so that would be the distance from the vertex B to the yellow plane. What does that mean? So first of all, we try to have this. Right, so this is, let's say, this is M. Good. So we try to define this first, and then this. We want this so much. All right, so first of all, okay, so part B, we try to define M is a point on CD such that BM is perpendicular to CD. And then at the same time, since triangle ACD and triangle BCD are isosceles, so that's why if BM perpendicular to CD, so AM is also perpendicular to CD. And then we try to find BM and also AM. So AB is 40. Right, so AM and BM. And then we have BCD. So maybe we can make use of the triangle on the left. Okay, so this is M. And then we have ACB, okay, in A2. And then we have BCD, so we can work out this angle. So this angle, and then we have AC, so that's why we have AM. So AM equals AC, found in A1. So sine 132 minus angle ACB. So we can make use of the answer in in A1 and A2 all together. That's good. So A times sine 132 minus B. So that will be 39.0 cm. So I think it's a must, okay, for us to save this answer to answer C, because okay, it will be used to find angle B, A and B. So this is C, AM is C. Okay, good. And then after that, okay, we need to find BM. Can we find BM? Maybe first of all we find CM then. So CM, so same case, okay, so CM goes to AC, cosine this time. Just change it. So that would be 17.9 cm. And then we are going to find BM because we have BC. BC is 24. So 24 square equals BM square, and then plus CM square. So that's why BM, so 24 square minus the answer we obtained just now, and take the square roots. So 16.0. So this one, okay, I would definitely pass it to be D. And just now the other side is also important, because if we have CM, then we can find out the base area. So never mind, I just try to plug it again. So yep, good. So that would be x. How about that? This is x. So now that's good, okay, because we have all the three sides. Let me draw that out then. So this is ABM. This is 40. We want this angle. And then BM is, where's BM? Oh, BM is D. And then AM is C. So note this. Good. And then we just try to find the angle. So cosine angle AMB equals to so AM squared plus BM squared minus 40 squared over 2 times AM times BM. So C squared, oops, plus D squared minus 40 squared over 2 times C times D. Arcs are fit, so 81.7. And then good. Okay, and then we have this angle, and then very important. Okay, we want the height. We want the height. So base times height, we will have AM. Good. So let's put it all together. So the volume. So that will be 1/3. So base area, base. Okay, so that would be cm times 2, or 2 cm. How about that? 2 cm. And then we have AM, and then divide by 2. So that's the base area, and then we want to times height. So that would be BM. Do we have BM? BM, yes. And then times sine angle AMB. And then we try to put all these together. All these to the calculator. So just cancellation. Good. CM, so that will be X, and then AM is C, divided by 3, and then times BM is D, and then times sine, the answer just now. So we have 3690. Okay, so that's 36, and to be more specific, and that would be 36x6.278 33xcm cube. And that's all for the last part, as well as the whole video. Thank you for watching.